factor the trinomial completely. So the first thing I want to do is I want to look for factors of the first term, 12a squared. Well, for 12a squared, I can go with a and 12a, or I can go with 2a and 6a, or I can go with 3a and 4a, 3a and 4a. And then I have to pair those off with the factors of 9. So let's see, for 9 I can either do 1 and 9 or 3 and 3. So 1 and 9 or 3 and 3. So I pair off all the factors of 12a squared with all the factors of 9. Then I just have to go through and see which pair possibly works. So let's start with the a and the 12a. The a and the 12a, I can match it up with the 1 and the 9. But I cannot put anything in a parenthesis with a term that has a common factor that's not 1. So I can't put the 9 with the 12 because 9 and 12 have a common factor of 3. So I have to put the 9 here and the 1 here. Now let's talk about the signs. Because this is negative, that means that the two factors will have opposite signs. And because this is negative, the larger of the outside, inside product will be negative. So the larger product will be negative. Well, in this case, the larger product would be the product of the two insides, which would be bigger than the product of the two outsides. So the product of the two inside terms would have to be negative, which means the minus would go here and the plus would go here. But this doesn't work because the outside product is a, while the inside product is negative, and what's that, 18, 108, negative 108a. And when you add those together, you don't get negative 23. So I move on. Moving on, I'm going to try now the a and the 12a with the 3 and the 3. But the problem is I can't put a 3 with a 12 because they have a common factor of 3. So neither one of these 3's can go with a 12. So that means not only will 1 and 9 not work, but 3 and 3 will not work, which means a and 12a is off the list of possibilities. So moving along, I move on to 2a and 6a. So I can try the 2a and the 6a with the 1 and the 9. If I'm doing that, I can't put the 9 with the 6 because 9 and 6 have a common factor of 3. So I'd have to put the 9 with the 2 and the 1 with the 6. Then, when I look here, if I'm trying to get, they have to have, one has to be a plus, the other one has to be a minus. The inside product here is still larger than the outside product. So the inside product is the one I want to make be negative, since this has to be a negative 23. And then the outside has to be positive. So let me see. The product of the outside gives me 2a, while the product of the insides give me negative 54a. And when I add those, I don't get negative 23. And once again, this isn't going to work, so I'm going to move on to 3 and 3. But the problem is I can't put either 3 with 6 because both 3's have a common factor of 3 with 6. So that means 3 and 3 is not going to work. I don't even have to try it. So that means 2 and 6 are out also. So I'm down to my last chance now. It has to be the 3 and the 4. So let's try the 3a and the 4a then. The 3a and the 4a. Oops. So the 3a and the 4a. Well, let's try the 1 and the 9. And with the 1 and the 9, I cannot put the 9 with the 3. So I'll have to put the 9 with the 4, and the 1 would have to go here. And then let me see. The outside product in this case gives me 27a. While the inside product gives me 4a. I need to make the bigger one of those negative. So I put a negative here, so the 3a times the 9 gives me a negative 27, and that means this has to be plus. They have to have opposite signs. And when I combine these, 4a minus 27a, that gives me exactly negative 23a. So this is the correct factorization. This is what I was looking for. Those are my two factors. And they work because they have opposite signs, so that the negative 9 times the positive 1 will give me negative 9 when I find the product. And then when I do outside, outside, inside, inside, I do get the negative 23. We check that.